this morning. So I hope that I can deliver all these 4 materials for this in this afternoon session, and hopefully, well, you understood everything. Jadi saya akan berikan semua material 4 slide ini sebisanya hari ini. Mudah-mudahan kalian bisa paham. And for the quiz, for your first quiz, it is only up to this slide. So wait. See here, the quiz is only up to linearization and differentials. So you don't have to worry about the extreme value and mean value theorem. Okay. There is a typo here. It should be related rates. So the first session here, we will study about the related rates. The slides is divided into 3 parts, which are problem strategy and some examples, and some challenges that we will try to tackle here in the class, and then a take-home challenge. So first, we learn about the problem strategy. How should we deal for some problems? And here we are taking some examples. Before I continue, is my voice clear in you?
Yes, sir.
Yes,
It's clear.
sir.
Okay. So basically, these are the steps that you need to know, that you need to familiar with if you are dealing with related rates. So first, when you got the problem, you draw a picture and name the variables and constants. Normally, you need to use t for time, and all the variables are differentiable function of t. So for example, if you have movement of a car, then consider the position as s and the velocity with the variable b, acceleration with the variable a, and all of them are the function of time, which is t. So contoh, kalau kalian punya problem, ya, gambar, ya, ilustrasinya sebisa mungkin, sebisa kalian, kemudian beri nama di masing-masing variabel dan konstantanya. Gunakan huruf T untuk variabel waktu. Dan variabel lainnya seperti misalkan kalau di contoh pergerakan mobil, ya, asumsikan bahwa posisi, kecepatan, dan percepatan semuanya dapat diturunkan terhadap T. That is the first step. The next step is for you to write down the numerical informations in terms of the symbols you have chosen, and then write down what you are asked to find, usually a rate expressed as a derivative and so on. Yang kedua adalah tuliskan informasi-informasi numerik yang ada, misalkan posisi awal adalah 150 meter dari bangunan A. For example, initial position of the car is about 150 meters from building A. That is the numerical information. And then write down what you are asked to find. Then you write, for example, how long do we need to take? How many seconds until the car arrive at the building A if it goes at at the average speed of for example 5 kilometers per hour. Okay. Misalkan pertanyaannya adalah berapa lama, ya, berapa detik atau berapa menit atau berapa jam mobilnya akan sampai ke bangunan A kalau dia berjalan dengan kecepatan 5 km per jam. That is the example. And then you write the equation that relates the variables. So for example, you may, in the car case, you can relate speed and velocity, which is that velocity is the derivative of speed, for example. So, ya, jadi kemudian Anda menuliskan persamaan yang menghubungkan variabelnya. Misalkan tadi contoh kasus di mobil, berarti kecepatan adalah turunan dari percepatan, dan seterusnya. And then you differentiate with respect to t and so on and evaluate. So for example, here we have a conical tank. Di sini kita punya tangki yang berbentuk cone. The water runs into a conical tank at the rate of 9 feet cube per minute. The tank stands point down and has a height of 10 feet and base radius of 5 feet. How fast is the water level rising when the water is about 6 feet deep? So, di sini ceritanya adalah air itu kita tuangkan, ya. Jadi ada air masuk ke tangki berbentuk cone dengan kecepatan atau dengan laju pengisian sebesar 9 feet cubic per menit, ya. Jadi volume terisinya setiap menitnya adalah 9 feet cubic. Bentuk tangkinya itu cone dengan titiknya ada di bawah, ya. Jadi semakin ke bawah semakin sempit. Dan tinggi dari tangkinya adalah 10 kaki, ya, 10 feet. Dan base radius dari cone itu adalah jari-jari dari lingkaran terbesarnya dari cone itu. Di sini kita punya base radiusnya adalah 5 kaki. Pertanyaannya adalah seberapa cepat permukaan airnya naik ketika ketika kedalaman airnya atau ketinggian dari bawah sampai ke permukaan itu adalah sekitar 6 kaki. So the first thing first, we draw the picture and name the variables and constant. Kita gambarnya, ya. Kemudian tuliskan nama variabel dan konstantanya. So we have the variables are volume of the water, and x as at t, of course. Y, which is the depth, is also a function of t. And then we write down the numerical information. Then we write down the numerical information, which is we have Dt equals to 9 feet cube per minute. Jadi kecepatan air masuk ke dalam cone-nya, ya, dVdt adalah 9 kaki cube per menit. And then the radius is 5 feet. The height of the cone is 10 feet. Jari-jarinya 5 kaki. Ketinggian cone-nya 10 kaki. And then the speed. We want to know what is the speed of the water rising. How fast the water rising when the depth is 6 feet. Jadi kita taruh. So here we put that one of the numerical information is y equals to 6 feet. Jadi kita taruh kedalaman 6 kaki. And then write down what you are asked to find. So what we are asked to find is how fast the water level rising when the water is 6 feet deep. Ya. Apa yang mau kita tanyakan adalah Ddt. So it's basically Ddt because y is the depth of the water from the bottom to the surface. Jadi y itu adalah kedalaman air ya dari bawah sampai ke permukaannya. Then what we are asked is Ddt, which is moving upwards here. And then the solution is we assume that v, x, and y are differential function of t. The constants are the dimension of the tank. So we are asked dy dt when y equals to 6 feet and dv dt equals to 9 feet cube per minute. And then we write an equation that relates the variables. Ya, kita tulis persamaan yang menghubungkan masing-masing variabelnya. What is the equation that relates the variable? It actually the volume of the cone. We know from our high school that the volume of a cone is actually 1/3 of pi times x squared times y. Sorry, here x is the radius and y is the height. So we know that the volume is 1/3 pi x squared times y. So here we know that this equation involves x as well as v and y. Up to this point, any question? Sampai di sini ada pertanyaan?
Sir, itu berarti habis V itu dikali X pangkat 2 dikali Y lagi ya?
Ya.
Oh, oke.
V is 1, jadi V adalah sepertiga px kuadrat Y. Ya. Why? Because we actually want to compute the volume of the water, not the volume of the cone. Ya. Karena kita mau menghitung perubahan volume dari air. Ya. Yang kita punya adalah perubahan volume dari air, bukan perubahan volume dari cone-nya. So in this case, we use y instead of 10 feet. Jadi di sini kita pakai y sebagai tingginya, bukan 10 kaki ya. Okay, and the problem is now we on the information that we have is only y and v, only related to y and v. So no information is given about x or dxdt in this question. So we need to somehow eliminate x. Jadi di sini tidak ada informasi tentang x ya. X itu adalah radius ini. Tidak ada informasi sehingga kita harus menghapuskan x somehow. How to do that? We see in the picture that the radius, the proportion between the radius and the height of the cone is about 5 to 10. So in this case, we know that x to y is actually y over 2. So x is actually y over 2. Jadi di sini kita lihat bahwa dengan segitiga ya, kita tahu bahwa perbandingan antara jari-jari dan ketinggiannya adalah 5:10. Sehingga di sini kita bisa buat x dibanding y adalah setengah, di mana x adalah setengah dari y. Therefore, in this case, we can rewrite the formula for the volume, which was 1/3 of pi times x squared times y, to be now pi over 12 times y cube. Jadi yang tadinya volumenya adalah sepertiga px kuadrat y, ya, karena kita punya x adalah y per 2, sehingga kita bisa tuliskan v sekarang adalah pi per 12 y pangkat 3. So in this case now we already eliminate x. Di sini kita sudah menghilangkan x dari persamaan. And then after that we simply need to take the derivative of the volume with respect to time, which is, okay, derivative of volume with respect to time is pi over 2 times dy squared dy dt, which is pi over 4 y squared dy dt. Jadi kemudian kita turunkan masing-masing ya, karena V adalah fungsi dari T, Y adalah fungsi dari T, dan kita ingin mencari turunan terhadap T, sehingga kita punya dv dt adalah pi per 12 kali turunan dari Y pangkat 3 terhadap T, ya, yaitu 3Y kuadrat kali dy dt. This is because we have the chain rule. Ya. Because Y is a function of T, then if you want to find the derivative of y cubed with respect to t, we have to derivate y cubed with respect to y multiplied by the derivative of y with respect to t. Jadi kita mau turunkan y pangkat 3 terhadap t, maka kita turunkan y pangkat 3 terhadap y dikalikan dengan turunan y terhadap t. Any question up to this point? Is it clear?
Yes, sir. It's clear for me.
For the other? For the rest?
Sir.
Yeah. Okay, now then we have finally what we want to find is actually what we want to find is actually dy dt ya. Jadi yang mau kita cari sebenarnya adalah turunan y terhadap t, nilainya berapa, karena because what we want to find is how fast the water level rising when the water is 6 feet deep. Jadi yang mau kita cari adalah seberapa cepat ketinggian airnya naik ya ketika airnya sekarang adalah 6 kaki dalamnya. So how fast the water rising is actually dy dt, because y is the height. So you know that how fast the water level rising is actually dy dt. So in this case, we know that we simply need to put pi over 4 times y squared to the left hand side of the equation, so that we get dy dt equals to 4 over pi y squared dv dt. Jadi karena kita mau cari dy dt, maka kita pindah semuanya yang bukan dy dt ke sisi lain ya. Jadi kita punya dy dt sekarang adalah 4 per pi e kuadrat kali dv dt. Then finally, we simply need to evaluate the value because we have the value y equals to 6 and dv dt equals to 9. Then we have that dy dt equals to dy dt equals to 1 over pi, which is around 0.32. Jadi karena kita sudah punya dy dt persamanya seperti apa, kita tinggal ganti sesuai dengan angka-angka yang kita punya. Baru kemudian kita dapatkan hasil akhirnya. Which in this case, at the moment in this question, the water level is rising about 0.32 feet per minute. Jadi pada saat ini ya, jawaban dari ini adalah 0,32 kaki per menit ya. For this example, any question? No? Okay, let's go to the next example. For the next example, we have a hot air balloon and a rangefinder here. Yeah. And the hot air balloon rising straight up from this point where my cursor is now. It rises up, and then we use the rangefinder to track how fast the balloon rising up at each moment. So in this case, we have that a hot air balloon rising straight up from a level field. Jadi di sini balonnya naik dari area yang sejajar dengan rangefinder with the where they are placed like 150 meters from each other. Jadi mereka ditaruh kira-kira jaraknya 150 meter dari satu sama lain ya. Jadi rangefindernya ada di sini di kiri, kemudian balonnya di awal ada di 150 meter dari rangefinder. And then at the moment, ya, pada saat ini ya, kita misalkan ya, the rangefinder's elevation angle is pi/4. Jadi pada saat ini menurut rangefinder sudut kemiringan yang dibuat antara pandangan rangefinder ke balon terhadap permukaan tanah adalah pi/4. And here we have that the angle is increasing at the rate of 0.14 radian per minute. Kita tahu bahwa sudutnya naik sekitar 0,14 radian per detik. Per menit. The question is, how fast is the balloon rising at that moment? So we use the 6 strategy steps. Draw the picture. Name the variables. We have theta, y, and t, and the constant 150 meters. So the variables are theta, which is the angle in radians, and the y is the height of the balloon above the ground. Jadi kita punya variabelnya ada theta dan y. Ya, theta adalah sudut dalam radian sesuai gambar ini. Kemudian y adalah ketinggian balon dalam meter dari posisi awal dari permukaan tanah. And in this case, we don't really need to give special symbol to the distance, 150 meters, because this is a constant. And then the second step, we write down the additional numerical information, which is d theta dt equals to 0.14 radian per minute, and theta at the moment is pi/4. And the third step is we write down what we want to find. We want dy dt when theta is pi/4. We write on the question. Jadi step 2 tadi kita tulis numerical information-nya. Kemudian step 3 kita tulis apa yang mau kita cari. Ya. What we want to find is actually how fast is the balloon rising. Jadi, seberapa cepat balonnya naik. So if y is the height, the distance between the balloon position and the original position and the surface and the earth surface. Jadi, misalkan y adalah posisi y terhadap permukaan tanah, then what we want is actually dy dt. Jadi apa yang mau kita cari adalah dy dt ya, when p is equal to pi/4. Jadi ketika p adalah pi/4. And then the fourth step is we write an equation that relates the variable y and theta. Kemudian langkah keempat adalah kita menuliskan persamaan yang menghubungkan y dengan theta. And in this case we know that tangent of theta is front of theta over the side of theta. Jadi kita tahu bahwa tangen theta adalah depan dibagi samping ya. So in this case, we know that the equation is y over 150 equals to tangent of theta, or y equals to 150 times tangent theta. Up to this point, any question? Is it clear?
Clear, sir.
Okay, and then the next step is we differentiate with respect to time using the chain rule. So in this case, we have that dy dt is actually 150 times secant squared theta times d theta dt. Jadi, kemudian langkah selanjutnya adalah kita turunkan terhadap t. Kalau tadi persamaannya tidak ada turunan, kemudian kita turunkan terhadap t sehingga kita punya dengan aturan rantai ya, turunan tangen theta terhadap T adalah secant kuadrat theta dikalikan dengan d theta dt. And finally, we evaluate with theta equals to pi over 4 and d theta dt equals to 0.14. And we find that dy dt is actually 42 meters per minute. Jadi di sini pada langkah terakhir kita evaluasi dengan numerical information yang kita punya, sehingga kita dapatkan ternyata saat tetanya adalah pi per 4, kecepatan balon udaranya naik ke atas adalah 42 meter per menit. For this example, any question? Is it clear? Is it clear?
Sir,
Ya.
I want to ask, berarti kita pasti pakai yang sec 2 pangkat 2 theta itu?
What do you mean?
Sorry. Maksudnya yang secant pi per 4 ini jadi 2. Nah, ini tuh kita pakai ini buat ngitung yang ini. Terus soal yang lain juga sama gitu, pakai seka.
No, it depends on the equation that you have. Jadi ini tergantung sama persamaan yang kalian dapatkan. In this case, we use tangent as the equation. Why? Because we have the information of the angle and the front side and the side and the front and the side of the angle. Jadi di sini kita punya sudutnya, sisi depan dan sisi miring. In this case, we immediately know that the equation that relates them is actually tangent, a trigonometric function which is tangent. Jadi di sini yang kalau kita punya sudut, sisi depan dan sisi miring, maka otomatis kita tahu, sudut, sisi depan dan sisi samping, maka otomatis kita tahu bahwa persamaan yang menghubungkan mereka adalah y per 100, tangen theta adalah sisi depan dibagi sisi samping, yaitu y per 150. That's why when we differentiate, we get the secant squared theta. Maka dari itu ketika kita turunkan tangen theta terhadap t, we know that theta is a function of t. So using the chain rule, we have that secant squared theta times d theta per dt. Jadi kita tahu bahwa theta adalah fungsi dari t, sehingga turunan dari tangen theta terhadap t, because we want to differentiate everything with respect to time. In this case, we have that. Jadi di sini karena kita mau turunkan semuanya terhadap waktu t, sehingga y harus kita turunkan terhadap t. Theta juga kita harus turunkan terhadap t. Karena kita punyanya tangen theta, maka kita pakai aturan rantai. Seperti itu, Rasha.
Oke, sir. Menjelaskan. Thank you. Clear, sir.
Okay, now let's talk about this. We have 4 challenges that we can learn in this class. Suppose that the radius r and area a of a circle are differentiable functions of t. Write an equation that relates ddt to drdt. This is still simple. So we have that dA dt equals to pi times 2r times dr dt. How do we get there? Okay. So r is a function of t. So d dt of r squared is equal to dr squared over dr times dr dt, which is 2r times dr dt ya. Jadi di sini kita diminta untuk mencari dAdt hubungannya dengan drdt ya. Karena kita tahu r adalah fungsi dari t ya. Sehingga untuk mencari turunan dari r kuadrat kita perlu menggunakan aturan rantai ya. Kita gunakan aturan rantai, ternyata kita dapat 2R ya. Turunan dari R kuadrat terhadap R dulu, yaitu 2R dikalikan dengan turunannya terhadap T ya. Untuk for this example, any question? Any question? Ada pertanyaan untuk contoh ini?
Sir.
Ya?
Sir.
Ya, Gahara?
I think no, sir.
No? Okay, is it clear? Okay. The next question. Suppose that the radius and surface area of a sphere are differentiable functions of t. Write an equation that relates dsdt to drdt. Do you want me to show it to you how to do it, or you can do it by yourself later at home? Which one you prefer?
I prefer with you, sir.
Okay. Okay, so this is still simple. So in this case, we have ds dt. What is ds dt? Well, can anyone help me here?
It's a derivative, sir.
What is ds dt?
Derivative. Oh, sorry. 4 PR square.
So 4 p
PR square.
be sure.
Wait.
R is the function of t, so we want to differentiate r squared with respect to t. In this case, we have what is inside this bracket? R. 2r. Yeah, so you see here. Yeah. If r is a function of t, so if we want to find the derivative of r squared over t, it means that we use the chain rule, which in the end get 2r times drdt. Ya. Jadi karena r adalah fungsi dari t, untuk mencari turunan r kuadrat terhadap t, maka kita turunkan dulu r kuadrat terhadap r, baru kita turunkan r terhadap t. Ya. Turunan r kuadrat terhadap r adalah 2r, dan turunan r terhadap t yang kita nggak tahu di sini. So in this case we have 8p r dr dt. Apakah jelas? Apakah jelas?
Jelas, sir.
Yes, sir.
Jadi V-nya itu nanti dikali 2 terus digabungin ya, jadi V R gitu. Oke.
The next one. So how is dV/dt related to dH/dt if R is constant? So to answer A, what we want to find is basically dV/dt. We differentiate everything with respect to t, and in this case we consider R to be constant. So we have pi R squared dH dt. Ya, untuk yang A, karena kita asumsikan R-nya konstan, maka R itu kita tidak turunkan ya. Kita asumsikan R-nya konstan, maka R kita tidak turunkan, sehingga hanya H yang kita turunkan. Kita punya H saja diturunkan terhadap T, ya sudah kita tuliskan dH dt. As for B, so can anyone help me for B? Now instead of R, we consider H to be constant. So what is dV dt? Dava Jihan. Dava Jihandiko.
Ya.
What is the answer for B? Apa jawaban untuk B? Apa jawabannya, Dava? Dava?
Bingung, Pak.
Bingung karena tidak mendengarkan. Kalau bingung kenapa nggak tanya tadi? Ya. Oke, Rachel. What is the answer for B? Rachel.
Yes, sir.
Yeah. What is the answer for B? We have the formula here. So what is dV dt if H is constant? Apa, Rachel? Ya.
PH.
P.
P8.
H. And then?
Di dr per dt.
Is it all? That's it, or you find something missing here?
Wait, sir.
You want to differentiate R squared with respect to T. What is inside the bracket?
R kuadratnya pakai R kuadrat ya?
It's 2R.
Oh, 2R.
Ini sudah diulang berapa kali ya dari atas tadi ya. Kita mau turunkan dr kuadrat. dt itu adalah dr kuadrat dr kali dr dt ya, yaitu 2r dr dt ya. So understood? So, Dava. Dava,
Iya, Pak.
sudah paham? Dava sudah paham?
Bentar, Pak.
I will make sure that this type of question appear in the quiz. Jadi saya akan memastikan bahwa soal seperti ini akan muncul di quiz ya. Quiz minggu depan. Okay, now for C. C, we assume that neither R nor H is constant. Then, Sharifah.
Sir, can I ask first something?
Jason.
Sir, itu kan dibilang relate to the R per dt and dH per dt. Berarti kan ada dua jawaban itu ya, Sir?
No, it's only one answer.
Oh, berarti paling belakangnya ntar pakai dr atau dH dong, Sir?
Both.
Both. Oh, okay. Okay, that's all. Thank you, Sir.
Sharifah.
Yes, sir.
Ya, what is the idea to answer C? Jadi kira-kira ide dari Sharifah gimana seharusnya saya menjawab untuk C? We have V equals to PR squared H. Ya, jadi kita punya rumusnya adalah V sama dengan PR kuadrat H, where V, R, and H are all a function of T, and we want to differentiate everything with respect to T. So, how should I do that? Jadi, kira-kira idenya gimana? V sama dengan PR kuadrat H, di mana semuanya ya, V, R, dan H adalah fungsi dari T. Kalau saya mau mencari dv/dt, apa yang saya harus lakukan? Cukup idenya saja, salah tidak apa-apa.
To P.
No, idenya saja, tidak usah jawabannya. Saya harus menggunakan aturan apa untuk mencari turunannya?
Maaf, sir, maksudnya gimana?
Jadi misalkan idenya pakai aturan rantai, pakai aturan perkalian, aturan pembagian, dan seterusnya.
Oh, pakai aturan rantai, sir.
And then? That's all? Okay, thank you, Sharifah.
Yes, sir.
Firya Alati. Firya.
Iya, Pak. Iya.
Yeah, how should I find the derivative of volume with respect to T in this case? Gimana seharusnya saya mencari turunan V terhadap T ketika R dan H-nya tidak ada yang konstan? Semuanya adalah fungsi dari T. Pakai aturan apa? Firya.
Iya, Sir. Maaf tadi itunya putus-putus suaranya. Jaringannya jelek, Sir.
Oke, Aziza. Aziza.
Yes, sir.
So how should I differentiate V with respect to T? Idenya seperti apa? Okay, the idea is using product rule. Ya, jadi idenya adalah menggunakan aturan perkalian ya. So how to do that? We have then in this case we have U to be R squared and V to be H. Yeah. So in this case we have pi times dr squared dt times H plus pi times R squared times dH dt, which is pi which is pi times 2p times pi times 2r times H dr dt plus pi times R squared dH dt. Is it clear?
Yes, sir.
Yeah. So in the end, we will have pi r multiplied by 2h dr dt plus r dh dt. Yeah. Okay, that is the answer. Any question before I continue with the next problem?
Sir,
Ya.
aku mau tanya, kenapa bisa diputusin untuk jadi perkalian?
Okay, this is an interesting question, which is very relevant. Let me copy this first. Yeah. Okay. Why? Let me answer it fully in bahasa so that you can understand. Jadi mengapa kita menggunakan aturan perkalian? Karena kita punya R sebagai fungsi dari T dan H sebagai fungsi dari T. Berarti kita punya perkalian antara R sebagai fungsi dari T dan H sebagai fungsi dari T. Kalau kita mau turunkan, maka kita harus menggunakan aturan perkalian. That's the answer. Understood?
Oh, paham, Sir. Terima kasih.
Okay. Yeah. Any other question? No?
Sir.
Yeah.
I want to ask, but what if we use the pembagian one?
Then that is fundamentally wrong then, in that case. Ya, jadi karena kita punya perkalian, maka tidak mungkin kita menggunakan aturan pembagian, betul nggak?
Oh, yes, ya betul sih.
Yeah, that's the idea. Okay.
Okay.
Now, this is the most challenging challenge. Water is flowing at the rate of 50 meter cube per minute from a shallow concrete conical reservoir vertex down of base radius 45 meter and height 6 meter. So first, we draw the reservoir. Pertama kita gambar reservoirnya. How to draw it? Here, the key is the reservoir is vertex down. Vertex down in English means that it points down. Jadi titiknya itu ada di bawah, ya. So the conical reservoir should look like this. So we have here, and then we have that the water flow out from here. Let's say we have a pipe. The water flows like this, yeah, down. So now we do the second step, which is to find the numerical information. Okay, the base radius is 45 meters. So here, the base radius is 45 meters. And the height is 6 meters. The water is flowing, then the volume dV dt is 50 meter cube per minute. And let's say here is the surface. So we have this as our height y. And we have that y is 5 meters. Okay, now how fast is the water level falling when the water is 5 meters? So the question is, for A, the question is dy dt at y equals to 5 equals to what value? Now we again write down the formula, which is v equals to 1/3 of pi times we do have the formula here, times px squared y. Okay, p let's say x squared y. Here is x, and we have that x over y is actually 45/6, which means that x is 45, okay, 15/2. So x is 15/2y. So in this case, we have that v is now equal to 1/3 pi times 15/2y squared times y, which is 225/12 pi y cube. So we have the equations. Now dv dt is actually 225/12 pi times 3y squared times dy dt, which means that we have dy dt equals to equals to 4 over 2 to 5, sorry, 2 to 5 y squared pi times dv dt. So in this case we can finish the job. Where we have that dy dt at times y equals to 5 is actually equal to 4 over 2 to 5 y squared. Sorry, 5 squared pi times 50. So we have that 8 over 2 to 5 pi. So the height will change in about 8 over 2 to 5 pi in this case. Okay. So any question?
Sir, saya mau nanya.
Ya.
Itu yang 4 dari mana ya, Sir?
4.
Yang
Yang
dy
mana?
per dt.
dy per dt, oh di sini.
Iya, Sir.
Yeah, it's because we have 3 over 12. So 12 divided by 3 is 4.
Oh, okay, Sir. Thank you, Sir.
Now, the next question is how fast is the radius? Now, the water level falling, we already done that. How fast is the radius of the water surface changing then? Answer in centimeters per minute. Oh. Okay, well, this answer is still in meter per min. Then we can change it to centimeters per minute. How to do that? We have 800 over 2 to 5 pi, yeah, which is actually 800 divided by 5 is 160 over, okay, 2 to 5 divided by 5, meaning that we have 1775 centimeters per minute, which is equal to 80 over, okay, I forgot the pi here, 80 over, no, not 80, but we have divided by 5 again, we have 32 over 15 pi centimeters per minute. Okay, that's it for A. And for B, actually what we want to have is how fast the radius, instead of the height, the radius change at that time, because we have x equals to 15 over 2y. In this case, we have that dx dt is equal to 15 over 2 dy dt, which means that dx dt at where y is equal to 5 is actually 15/2 times what we have there was 32/15 pi centimeters per minute, which is 16/pi centimeters per minute. Yeah. Here is how you should do it in your quiz or midterm. Yeah. Any question? Jadi tadinya kan kita hanya diminta untuk mencari Ddt untuk A ya, karena seberapa cepat ketinggian airnya turun. Kemudian pertanyaan kedua adalah seberapa cepat radius dari airnya, dari permukaan airnya turun. Kita tahu bahwa hubungan antara ketinggian dan radiusnya adalah X sama dengan 15/2Y. Sehingga ya kita tinggal turunkan X sama dengan 15/2Y, dua-duanya terhadap T, baru kita masukkan nilai Ddt-nya. Karena Ddt-nya kita sudah dapatkan sebelumnya, yaitu 32/15 pi cm per menit, sehingga dxdt-nya kita bisa hitung dengan lebih mudah. Any question up to this point? Any question?
Sir,
Ya.
untuk itu yang 880-nya itu kan dibagi 5 ya?
800 ya, bukan
Nah,
800.
yang saya ketemu tuh 880. Ya.
800 bukan 880.
Oh. Oke. Berarti saya yang salah, sir. Sorry.
Excuse me, sir.
Ya.
Yang 225 tuh yang dibagi apa ya? Enggak 45 ya, sir?
You mean 225 divided by 5? 225 dibagi 5 maksudnya?
45 nggak, sir?
Yeah, maybe. Thanks for the correction. 225 divided by 5, okay, it should be 45. Then I made a mistake here. It should be 45. Good observation. Then if we divide it by 5 again, we have 45 divided by 5 is 9, right? Yeah. Yeah, and then here it should be 9, not 15. So we have 16 times 15 divided by 9 is actually 5/3, and 5 times 16 is 320. Sorry, 5 times 16 is 80. 80/3 pi. Okay, yeah, good observation. Thank you for the correction. Ya, terima kasih koreksinya. Okay, that's all for this slide. There are some challenges that you can do at home. Make sure to learn about this because it will appear in the quiz. Now 7, yeah, about linearization and differentials. So what is actually linearization? Linearization is this thing. So if we have f differentiable at x equal to a, then we can approximate the function around a by this function, and this function is actually the linearization of f at a. Jadi apa itu linearisasi ya? Kita mau mendekati nilai dari fungsi f di titik x sama dengan a. Maka apa yang perlu kita lakukan? Kita membuat fungsi ini. So in this case, actually any point x around a will be, the value of the function f and r will be approximately the same. Ya. Jadi di semua titik x di sekitar a yang sangat dekat dengan a, nilai dari fungsi f itu akan cukup dekat dengan fungsi l. So in this case, we can actually use this linearization as our mean to approximate a certain function. Ya. Jadi di sini kita bisa mendekati nilai dari suatu bilangan yang mungkin sulit untuk kita temui, untuk kita hitung sendiri, tapi kita tidak punya kalkulator. Kita bisa gunakan linearisasi ini. For example, find the linearization of f of x equals to square root of 1 plus x at x equal to 0. Now, we know that the derivative of f with respect to x, which is f prime x, is equal to half 1 plus x power minus half. Jadi kita tahu turunannya adalah setengah kali 1 plus x pangkat min setengah. So in this case, we have f0 equal to 1, and also f prime 0 equal to half. Then we have the linearization. We use this formula. We use this formula from this slide. We put everything inside, and then we get that the linearization is 1 plus x over 2. Jadi kita dapat ternyata hasil linearisasinya adalah 1 plus x per 2. So in this case, if we want to approximate the value of 1.2, we want to approximate the value of square root of 1.2, is actually we can approximate it by the this function, yeah. So 1 plus 0.2 over 2, which is around 1.10, but actually the truth value is 1.095445. Ya. Jadi di sini kita ilustrasikan ya, kita punya hasil linearisasi dari fx sama dengan 1 plus akar x. Hasil linearisasinya adalah 1 plus x per 2. Jadi kira-kira kita bisa mendekati nilai dari akar 1,2, karena akar 1,2 itu kita bisa buat sebagai akar dari 1 plus 0,2. Berarti di sini x-nya adalah 0,2, kita pakai linearisasinya, ternyata kira-kira nilainya adalah 1,10. Dan ternyata kalau kita pakai kalkulator, ya, nilai sebenarnya itu cukup dekat, ya. Nilai sebenarnya adalah 1,095445. So you see here that the error is actually less than 100, less than 0.001. Less than 0.01. Sorry. And then we want to approximate the value of square root of 1.05. Since we know that 1.05 can be written as 1 plus 0.5. 0.05. Then we can use the linearization to find the approximate value. So in this case, it is easier to compute. Yeah. We know that the approximated value is about 1.025. Yeah. And turns out that the true value is 1.024695. Jadi di sini kita coba mendekati nilai dari akar 1,05. Ya, karena kita tidak punya kalkulator, kita linearisasi akar 1 plus x menjadi hasil linearisasinya adalah 1 plus x per 2. Setelah kita linearisasi, kita gunakan linearisasi ini untuk mencari nilai dari 1,05, yaitu kira-kira 1,025. Ternyata dengan nilai sebenarnya cukup dekat, ya. And so on and so forth. Ya. So next example. Now we want to find the linearization around x equal to 3. And it means that the center x is different. So here we have that f3 equal to 2, f prime 3 equal to 1/4. Then we have the linearization is now different. The linearization is now 5/4 plus x/4. Yeah, we use the same formula. We just change a. Yeah. Up to this example, any question? Up to this example, any question? No?
I think no, sir.
No? Is it clear?
It's clear.
Yes, sir.
Sir, before this, jadi yang tadi approximately itu kita bisa dibulatkan ya, Kak?
Yeah. Yeah, somehow you can say something like that.
Okay.
So, and then now, before we go to the challenge, I introduce another notation, which is differentials. So what is actually differential? So suppose that we have y equals to fx, which is a differentiable function. Then the differential dx is an independent variable. Differential dy is dy equals to like this. Jadi apa itu diferensial? Diferensial itu kita hanya mengambil dx-nya saja atau dy-nya saja. Gitu ya. Because here if we put the dx on the left hand side of the equation, we have dy dx equals to f prime x. Ya. Jadi di sini kalau kita pindahkan dx-nya ke sebelah kirinya sama dengan, kita dapat dy dx sama dengan f aksen x. Ya. Yang mana itu adalah definisi yang sudah kita kenal sebelumnya. Ya. The only difference is that now we write it in this way. Ya. Perbedaannya hanya kita sekarang menuliskannya seperti ini. For example, find dy if y equals to x power 5 plus 37x. Then the solution is simple. Yeah. Find the derivative and then multiply by dx. And then find the value of dy when x is equal to 1 and dx is equal to 0.2. Then we simply substitute the value. Ya, jadi kita mencari seberapa jauh y berubah. Nah, jadi arti dari diferensial ini sebenarnya seberapa jauh y berubah ketika x berubah. So that's why we write dy equals to f prime x dx. So in this case, we know in the b case, we know how far dx move. Jadi di sini kita tahu seberapa jauh titik x berpindah, yaitu 0,2. In that case, we know how far the y move at that exact moment. Jadi ketika kita tahu, oh kalau x-nya 1, terus kita pindahkan x sejauh 0,2, ya, kita tahu y akan berubah sejauh berapa. It turns out that in this case, when x move for about 0.2, the value of y move for about 8.4. Jadi kalau x berubah sejauh 0,2, yang mungkin misalkan menjadi 1,2 atau 0,8 misalkan, nilai dari y-nya akan berubah sejauh kira-kira 8,4 ya. Jadi kira-kira tanpa menghitung y sama dengan x pangkat 5 plus 37x untuk x sama dengan 1,2 atau x sama dengan 0,8, kita tahu kira-kira y-nya akan menjadi berapa? Y-nya akan berpindah sejauh 8,4 ya. So in this case, if x equal to 1, the value of y is actually 38 ya. Jadi ketika x sama dengan 1, nilai dari y-nya adalah 38. So when x move for about 0.2. So we want to know the value of y at x equal to 1.2. The value might be jadi nilainya mungkin ya kira-kira 38 ditambah 8,4 ya, kira-kira that is the illustration. Now is the real. I can say that this is a real world example because you may find this many times later in your life. So we've used differential to estimate 7.97 power 1/3. So we know that here we have a cube root function which is y equals to x power 1/3. Jadi kita tahu kita mau mengestimasi 7,97 pangkat sepertiga. Kira-kira berapa nilainya? Nah, ini kita asumsikan kita punya fungsi yaitu y sama dengan x pangkat sepertiga. Then we find the differential which is actually dy equals to 1/3x power 2/3 dx. Kemudian kita cari diferensial dari dy. Sehingga kita dapat diferensialnya adalah 1/3x pangkat 2/3 kali dx. Now, in this case, we can set a equals to 8, which is the closest number near 7.97, where actually we can easily compute fa. Ya. Jadi, di sini kita pilih a sama dengan 8. Kenapa? Karena kita punya a pangkat sepertiga. Ya. X pangkat sepertiga. Berarti X pangkat sepertiga itu kan akar pangkat 3 dari X ya. What is the 8 power 1/3? Berapa nilai dari akar pangkat 3 dari 8? Berapa nilainya?
2.
2 ya. So 8 power 1/3 is 2. And we know that 8 is very close to 7.97. Jadi kita pilih angka 8 karena dia dekat dengan 7,97 dan kita bisa menghitung dengan mudah FA dan F aksen A. Ya. So in this case we have that A plus dx equal to 7.97, which means that we can choose dx to be minus 0.03. Why? Because 8 minus 0.03 is actually 7.97. Yeah. So we can approximate the value of f 7.97 by this differential by using the differential, which is about 1.9975. Jadi kita bisa mendekati nilai dari 7,97 pangkat 7,97 pangkat sepertiga dengan dengan memilih a sama dengan 8, memilih fungsi y sama dengan x pangkat sepertiga, kemudian kita bisa dapat dx-nya adalah minus 0,03, sehingga kita bisa dapat nilainya kira-kira ya segitu. Any question? Any question? No?
No, sir.
Is it understood?
So I want to ask.
Ya.
Closest number itu berarti dibulatkan ya, sir? Kalau seandainya dia 7, kan kalau pembulatan itu di bawah 4 itu kan dibulatkan ke 0 ya, sir? Kalau dia seandainya 7,4 berarti dibulatkannya nanti itu ya set A-nya itu 7 ya, sir?
It's not always like that. So here we find the closest number that is easily that can be easily computed. Jadi kita mencari bilangan terdekat yang mudah untuk dihitung, ya. Because we have f of a equals to f of x equals to x power 1/3, ya. Karena kita punya fx adalah x pangkat sepertiga. In this case we can choose a equals to 8, ya. Kita pilih a sama dengan 8 karena apa? Karena halo.
Ya, sir.
Pilih A sama dengan 8 bukan karena pembulatan, tapi karena 8 adalah bilangan yang kita tahu akar pangkat 3-nya. That's it. That's actually the idea.
Oh, okay, sir. So how about if the 7.97 become 7.4?
We can still choose 8, for example.
Why not
We can-
7, sir?
Yeah. Why not 7? Because in this case, we don't know the value of 7 power 1/3. Ya, karena kita nggak tahu nilai dari 7 pangkat sepertiga berapa.
Oh.
Ya.
Okay.
So basically this is the formula. Okay. This is the formula. So we want to approximate f of a plus dx by f of a plus dy. And we know the dy is like this case. Yeah. Understood?
Yes, sir.
Yeah. Now the next, yeah, any question? Any question? No? No? Okay. Now the next question, yeah. Here we want to estimate the value of sine of pi over 6 plus 0.01. Kita diminta untuk mencari nilai dari sin pi per 6 plus 0,01, ya. In this case, we know the value of sin pi over 6, ya. Kita tahu nilai dari sin pi per 6 berapa? Pi over 6 is about 30 degree. So sin 30 is
30.01.
no. Pi per 6 itu kira-kira 30 derajat,
30,
ya. Jadi sin 30 derajat berapa?
Half.
Setengah, ya. So sin pi over 6 is half. So we know the value of sin pi over 6, but here we are asked to find the value of sin pi over 6 plus 0.01. So here we choose the equation to be y equals to sin x, and then we find the differential, which is dy equals to cos x dx. Then to estimate the value of sin pi over 6 plus 0.01, we set a to be pi over 6 and dx to be 0.01. Why? Because we know the value of sin pi over 6, so that we can easily use this method to compute the value of sin pi over 6 plus 0.01. Ya. Karena kita tahu nilai dari sin pi per 6, maka kita pilih A-nya sama dengan pi per 6. Sehingga kita bisa dengan mudah mencari nilai dari sin pi per 6 plus 0,01. Ya. And here is how you do it. So in the end, approximately the value of sin pi over 6 plus 0.01 is around 0.5087. Ya, jadi kira-kira nilai sin pi per 6 plus 0,01 adalah 0,5087. Ya. Understood? Bisa dipahami?
Bisa, sir.
Now we have like 5 challenges. Yeah. So now let's try to do this to finish this challenge together. Okay. First, find the linearization of L of f of x at x equal to a. As usual, Oops. Now, what is the derivative of f of x? So we have that f prime x is equal to, okay, you can try to find f prime x by using chain rule, but let me tell you the answer. The answer is 2x over, no. The answer is x over square root of x squared plus 9. Jadi turunan fx, turunan dari akar x kuadrat plus 9 adalah x per akar x kuadrat plus 9. So in this case we have that f of a equals to minus 4 is actually square root of 16 plus 9, which is square root of 25, which is 5. And then f prime at a equals to minus 4 is actually minus 4 over 5. So the linearization is L of x equals to f of a plus f of x, plus f prime of a times x minus a. We work according to this formula. So in this case, we have that the linearization is now 5 plus, sorry, not plus, but minus 4 over 5 times x plus 4, which is about 5 minus 16 over 5. So 5, okay, 9 over 5. 9 over 5 minus 4 over 5x. Jadi linearisasinya adalah seperti ini ya. Any question? Any question? No. Then let me go to the next example. Find the linearization and assertively choose an integer near a at which the given function and its derivative are easy to evaluate. So in this case, we have f prime of x is one over 3x power 2 over 3, 2 over 3. Yeah. And so we have f of and we choose integer near a at which the given function and its derivative are easy to evaluate. So which a should we use? Jadi kita diminta untuk mencari bilangan ya, misalkan bukan A deh, B ya, yang dekat dengan 8,5 ya, bilangan bulat di sini. Sedemikian sehingga fungsi dan turunannya mudah untuk dihitung. Kita pilih B sama dengan berapa?
8, sir.
8 ya. B equals to 8. Ya, B-nya sama dengan 8. So in this case, the linearization is L of X is actually F of B plus F prime of B times X minus P, which is okay, F of B is equal to 2 and F prime of B is equal to 2 squared 4. Okay, F prime of B is 1 over 12. Yeah. You can compute it by yourself. Then we have that the linearization is now equal to 2 plus 1 over 12 x minus 8, which is 24 minus 8 is 16 over 12 plus x over 12. Yeah. So this is the linearization because we are asked to find the linearization at a suitably chosen integer. Ya, jadi near A. Ya. Jadi kita diminta untuk mencari linearisasi pada bilangan integer terdekat yang dekat dengan E yang kita punya gitu ya. That is how to do it. And then the next challenge this is the same.
Sir,
Ya,
boleh ke challenge pertama, sir? Tadi lagi catat, cuma nggak keburu.
okay. This one.
Okay, wait, sir. Okay, sir. Thank you, sir.
So in this third challenge, we have actually, okay. What is the f prime of x in this case? Apa turunan dari fx terhadap x? What is f prime? Apa turunannya dari e pangkat min x? Halo.
Minus x times e power minus x.
Minus e power minus x.
Yeah.
So now, what is the integer that we choose that is near a? B equal to, so that we can easily compute the value of e power minus x. Jadi berapa nilai integer yang dekat dengan minus 0,1 sehingga kita mudah menghitung e pangkat minus x. What is it? 0. Okay. Why? Because f of 0 is equal to e power 0, which is
1.
1. And f prime 0 is equal to minus e power 0, which is minus 1, right?
Yes.
So that's why we choose 0 in this case. So we have that the linearization of f is now f of b plus f prime of b times x minus b, which is 1 minus 1 times x minus 0, which is equal to 1 minus x. Is it clear? Ya, apakah ini jelas?
Yes, sir.
Now the last two challenges show that the linearization of f of x okay, even though the statement is quite different, but actually what we are doing is the same. So let u equals to 1 plus x, then u prime is 1. Okay, then we have that f prime x is equal to df du times du dx, which is ku power k minus 1 plus sorry, not plus, but times 1. So in this case we have that the derivative is k times 1 plus x power k minus 1. So f0 is 1 plus 0 power k, which is 1 power k. What is the value? 1 power k, 1 power anything, still equal to
1.
1. What is the value of f prime 0? K times 1 plus 0 power k minus 1, which is k times 1 power k minus 1. What is it?
1.
K times 1, so it's k.
Yeah,
right?
k. Yeah.
So in this case, we have that the linearization is now equals to f0 plus f prime 0 times x minus 0, which is 1 plus kx. Yeah. Is it clear?
Yes, sir.
Yeah. Now the last write a differential formula that estimates the given change in volume or surface area for the change in the volume V. Yeah. So we have V. So how big the volume change when the radius change? The radius change for about dr. So in this case, actually what we want to find is dv dr, which is, okay, what is dv dr? What is the derivative of v with respect to r in this case?
Pardon me, sir.
Jadi di sini kita diminta untuk mencari rumus diferensial yang bisa memperkirakan ya, berapa perubahan volume kalau volumenya adalah 4/3 pi r pangkat 3 ya, ketika radiusnya berubah dari R0 ke R0 plus dr. So in this case, what we want to find is actually dv dr, ya, derivative of v with respect to r. Jadi sebenarnya untuk contoh ini yang mau kita cari adalah turunan v terhadap r. Turunannya apa? What is the derivative? Ya, turunannya apa? Halo?
R power 2, sir.
4p r squared, right?
Yes, sir.
So in this case, we have that dv is equal to 4p r squared dr. Okay, so this is the answer. Yeah, understood? Bisa dipahami?
Sir,
Yeah.
I want to ask, but where the number 3 go?
You mean 4/3?
Yang tiganya itu jadi dikemanain ya?
Oke. V sama dengan 4/3 pi r pangkat 3. Berarti dv per dr adalah 4/3 kali pi kali 3r kuadrat. Kan ya, tiganya bisa kita coret. Sehingga kita punya 4 pi r kuadrat. Is it clear?
Oh, okay. Clear, sir. Thank you.
Yeah. Now the time is actually up, but there is one interesting challenge that I want to illustrate to you. Okay, we use the approximation 1 plus kx to estimate the following value. Jadi di sini kita diminta untuk mencari nilai dari 1,0,002 pangkat 50 ya. Berapa nilainya kira-kira ya. So, how to do that? This one is quite simple and please make sure to take a note because it might appear in the quiz. Yeah, so kalau kita menghitung ya, if we compute directly 1.0002 power 50, then there will be so many zeros which we may not be able to write, or maybe our calculator cannot compute it, but we can estimate the value easily by using this equation. So basically 1.0002 is equal to 1 plus 0.0002. So in this case, we have that 0.0002 to be our x. So in this case, 1.0002 power 50 will be about 1 plus 50 times 0.0002, which is around 1.01. Yeah. So this is the approximate value, and the next is, okay, what is 1.009 power 1/3? We have that we have it approximately 1 plus 1/3 times 0.009, which is about 1.003. Yeah. So we can actually be faster than our calculator if we know this trick. Ya. Jadi kita sebenarnya bisa lebih cepat dari kalkulator kita kalau kita tahu trik ini ya. So this is the end of our afternoon session. Any question before I close the session? Any question? No?
Okay, sir, can I lock the screen again? Wait. Okay, done, sir.
So basically, this is the benefit of using linearization. We can estimate the value of a certain operation easily. Yeah. So let me end the recording now, and I want to talk to you about the quiz.